Okay, let's continue our review and practice of simplifying radicals. Now, we start off with, and hopefully you did this before during first trimester, but if we start off with the square root of, let's just start with 50. Okay, now remember what I suggest that you do is I divide this by 2, which is 25, and then I start thinking about my perfect squares. Perfect squares: 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, and so forth all the way through there. And I want to find the biggest perfect square that will divide into 50. Well, that happens to be 25 and 2. Remember, the first number that I put down here every single time, this one right here, is always going to be a perfect square. And it's always going to be the largest. I could do smaller, but that just means I have to do it more than once. If I do the largest, I'll be done with this one time. So when I do this, the square root of 25 is 5. So it's times the square root of 2, and that's it. All right. Now let's say that I take the square root of 48. All right. Now the square root of 48 is a tough one because 48 has a lot of them. A lot of you will see, okay, that's 4 times 12. And you're right. So that means this is 2 times the square root of 12. But now I got to look at this square root of 12. That's an awfully big number. Usually this number underneath the radical sign should be pretty small. Well, 12 can be broken down into 4 times 3. Well, the square root of 4 is really 2. So this ends up to be 4 root 3. Now, this is an example of why I think it's smarter to go big first. If I do this, it will be the square root of 16 times the square root of 3. Okay, and then I get 4 root 3. Now, I've graded and seen a lot of students' papers that when they get here, they think they should take the square root of that. So they end up saying that this is the square root of 4, square root of 3. This is 2 root 3. They circle that to go on. Well, that's incorrect. What we've done, what we've shown right here, that's the perfect answer. That's what I'm after right now. Okay, that's the correct answer. Without that, that's an incorrect answer, so then I want to stop. Now, that's just review. Hopefully you guys have done this in the past. Now let's start adding some variables in here. Now remember, when I take x to the, let's take it to the 10th, when I take anything like this, I'm going to try to I'm going to look for, when I do this, I'm going to look for the biggest number that will go in there. Well, here's the problem with this. What happens when I do this is I want the same number times the same number makes that. Well, when I do this, when I talk about underneath the radicals, I'm not x times x is x squared. So what I'm doing is I'm taking these and I'm adding them. So what I want to do here is I want to take these and I want to split them into 2. So I want to get, this will be x to the 5th squared. There's 2 of them. So what this is the square root of x to the 10th, the square root of x to the 10th. This little pointing thing is driving me nuts. And now I can't get rid of it. Okay, so let's start this one over. The square root of x to the 10th. What that is the square root of x to the 5th times the square root of x to the 5th. Because x to the 5th to x to the 5th is x to the 10th. Well, what this ends up to be is just x to the 5th. Because these two numbers are the same, I can do this. What happens whenever I have a square root of x to the 4th? Well, to get this, to get to the 4th, I don't take x squared times x squared. So that's my answer. All I do with this particular number is I divide it by 2. So the square root of x to the 100th, x to the 50th, the square root of x to the 92nd, x to the 46. Nothing's happened there. That's all. It's really that simple. Okay, so now let's make sure, let's rub these in a little bit harder. Let's put 2 of them. Notice both my exponents are even. As long as those exponents are even, this is a piece of cake. This is x to the 4th, y to the 5th. All right, because 4 times 2 is 8, and 5 times 2 is 10. Let's say that I put a number out in front of here. Okay, square root of that, well, that's going to be just, the square root of 4 is 2, and I just divide all the even exponents by 2. So I get there. What happens if okay, I can't break down the square root of 5. So this is, because these are even exponents, those go here, but the square root of 5 goes in the back. So this is x to the 4th, y to the 5th, square root of 5. All right, now we're starting to roll a little bit. So now let's say I take 72 x to the 4th, y to the, I don't care, let's say 12. Okay, 72. I know I think 9 times 8, but actually I want to think bigger. That's 36. Take half of 72 and start there and work my way down. Well, 72 ends up to be a perfect square. Both those exponents are even, so I got that made. Don't have to mess with those. Both those could work out. So it ends up to be 6x squared y to the 6 root 2. Now the question should be is, what happens if they're not? Let's say I have y, the square root of x to the 3rd. Here's what you do. Take out the biggest even and leave the 1. Notice that 2 plus 1 is 3. So the square root of x squared is x, and the other part just comes on for y. All right, now, is it really that simple? It is. X to the 17th, y to the square root of x to the 17th, y to the 9th. I want to take out the biggest positive I can, biggest even, out of both those. What's left? 1x and 1y. Because 1 plus 16 is 17, and 1 plus 8 is 9. Well, take half those exponents. Oops, that's more like 8. This is more like 4. And the other part comes along. Let's put all this together. So let's go with 24, x to the 5th, y to the 9th, z to the 10th. 24, half of 24 is 12. Will 9 go into it? No, will, 4 will. So this is 4 times 6. X to the 5th, that's an odd. So let's take out the biggest even and leave that 1 there, because now if I add those exponents, I get 5. Y to the 8th, 1 more out here. 1 plus 8 is 9. Z to 10, hey, that's even. Let's take all those bad boys there. Square root of 4 is 2. Take half of these exponents. The other part, those are leftovers. Those just come along for the ride. Okay, that's probably more than enough for you guys to be able to do this video, do this assignment today. Okay, this assignment will be due, I believe it's due on, today's Tuesday, Wednesday, so it's due on Thursday. All right, because the other class has that has this the other class. All right.